So this is, well, so I'm glad we got 6 people. That's great. So this is, I'm going to talk about MySQL to Mongo replication. And what I was going to do is I had some slides I was going to run to explain how it works. And then I'll show you a demo, and then we can just take it wherever it seems natural to go. My goal here is, so my name is Robert Hodges. I work for Continuent. I'm actually president of the company, but more importantly, I wrote the implementation for this replication, which is about 800 lines of Java code, as it turns out, within a much, much larger piece of software. So we have this thing called Tungsten Replicator, and have you guys ever heard of it?
No, you just mentioned it earlier.
This is excellent. This is excellent because you know, it's fairly well known inside, you know, sort of the hardcore MySQL world. That's where we started, and we're just kind of beginning to reach out to other databases. So that was one of the things I was hoping to do, just explain what it is, and then you can see if you like it. So basically, this is it, 25 words or less. That's exactly 25 words, including the URL. So it's basically open source replication. I sometimes call it, because we do commercial stuff. This is just a dev talk, but I often call it Golden Gate without the price tag because it's free. I mean, if you can use GPL v2, you're great. It's basically a message engine, as you'll see in a minute, that's optimized for replication, and we focus on open source databases. So we kind of grew up in the MySQL world. That's where the company started out a long time ago before I joined. It's entirely written in Java, and it's designed to be fast and flexible. I think you'll see some examples of that. And it's hosted out on code.google.com. And because we're MySQL guys, this is 100% open source, but we use kind of the MySQL model where we do all the commits, that anybody who wants it can grab it, use it, patch it, whatever they want to do. That's a picture of our home. It's pretty beautiful. So does anybody here use code.google.com? It's really good. I've been very, very impressed with it. So if you go out there, you'll find everything associated with the project. I'll talk a little bit more about that in a second. So the replicator features, do you guys use replication at all? How familiar are you with it? This is
a little bit.
Long
okay,
time
so,
ago.
I mean, like my previous job we used it a lot, but I
right.
don't use it now.
So this is kind of predicated, you know, tuned toward people who've been using MySQL replication are pretty familiar with these features, but we have everything from sort of these arcane things called global transaction IDs, and that means that every time we get something into the replicator, we give it a monotonically increasing ID, so that if we're like propagating data out to a bunch of slaves, the master fails, we can go around and query the slaves and say, which of you guys has the highest ID, promote that guy to master, and then all the other slaves can just connect to it, and whatever ID they were on, they just ask the master, and the master knows what they're talking about. So this is really critical for getting failover to work in distributed environments. And then it's just a whole raft of features all the way down the bottom. Parallel replication is something we put in. It was basically funded by Facebook, sort of as that's been our biggest project this year. And what we're doing is applying things to MySQL in parallel, and that's something Facebook is pretty interested in, but a lot of other people are as well. It helps, it like really cuts down slave lag. So it's kind of, as I say, it's kind of like, you know, the sort of features you get if you went to Quest or Golden Gate. It's just in this GPL v2 software. Here's how it works. So I used to work on transactional messaging in Sybase about 15 years ago, and I never totally got it out of my system. So when we built this thing, we basically built it as a messaging engine, and it has these things called pipelines, and you can have multiple pipelines inside a replicator. It means that's a replication flow. It gets events from somewhere, we call them events, but those are transactions from somewhere, and puts them somewhere. And within it, it has these things called stages. And the stages are, if you've ever used messaging or ETL software, they tend to have these kind of symmetric interfaces. So for example, in this we have a couple, this is a simple pipeline, we have a couple stages, and one's in fact I'm gonna step away from this microphone. Can you guys hear me okay? The microphone drives me nuts. So we have this really simple thing where we're extracting out of a MySQL bin log, or we could be getting it out of Postgres Sloaney log or Oracle CDC. And then you can filter, which means you can sort of edit or drop or observe the transactions as you go through, and then you apply. And in this case, it applies into an in-memory queue. And then there's another extractor. It's the same interface internally, but it's pulling out of the queue, can filter again and apply into a slave database. So it's kind of built like Lego blocks. And what we've done here, this pipeline is a real simple implementation of dividing readers and writers with an in-memory queue so that they aren't blocking on each other. And we have a bunch of little features like the appliers can be, the end stage can be parallelized. We call that parallel apply. That's really important. That's in fact the whole Facebook project. You can have we have a transaction log or in-memory queues, and then we have this thing called block commit, where in MySQL, you may have committed, like 10,000 transactions individually, but what we're going to do is read them, and we have block commit, which allows us to take them, say, 100 at a time, jam them into the slave, and then commit them so that we amortize the commit costs over time. So it's a fairly robust architecture for dealing with this kind of problem.
Question.
Yes.
You're talking MySQL here, but up there I see other databases also.
Yes, we support those as well. I'll show you. Yeah, we grew up on MySQL because for replication in relational databases, it's like building cars for the German Autobahn. If you can build them there, and they work on the Autobahn, then you can take the show on the road. And that's sort of been, we've been focused on getting it to work on MySQL, and now we're kind of spreading out to other databases. So we added Sloaney logs. We have sort of a very basic implementation of reading Postgres Sloaney logs. And we just recently started to read data from Oracle Change Data Capture. That's very, very prototypey, and it sort of barely works, but we're building that out. In fact, here's sort of the combinatorics. The databases, the dotted lines are the ones we're working on replicating out of, and I think the CDC, if you know Oracle, that's kind of flaky. We're probably going to try and tap into streams. In fact, I just bought a book down at Oracle, and we'll probably work on that over the next 6 months. But MySQL is the one we really support well. We've been doing this for about 4 years. And then Postgres, we're beginning to do that. But the key thing in here today is replicating from MySQL to MongoDB. And I just picked it because a lot of MySQL people are using Mongo, and I kind of like it. Have you guys used Mongo?
A little bit.
I like it. It's really easy to use. I don't know that I would want to build big applications on it, but it's a very, very nice database to just play around with. Kind of the way MySQL was when it was young. So here's how let me show you how the replication works. When we're actually going from MySQL to Mongo. So basically what we do is we tend to run separate processes. So you just run a Java process, and it's going to want about a gig of memory, or really about a gig of VM. The working set size tends to be a lot smaller. So you'll run it either on your master host, or maybe in a machine that can connect to it. And it's going to suck the bin logs, either talk to MySQL. If it's running remotely, it'll log in as a client, or it can just tail off the disk. There's advantages to each way. And then it stores them in its own transaction history log, which is kind of like a supercharged bin log. We identify shards, we put in global transaction IDs, and a bunch of stuff like that. And then the slave is another process, and it just dials up using TCP/IP and pulls them down. So it's a pull. Even though the arrows show flow of direction, it's actually a pull replication scheme. And then it writes it again into the transaction history log so that if the master goes away, we've got a copy, and then applies it to the slave. Because it's in Java, we always use Java APIs, although we're thinking of branching out from that for data warehouse loading. Does that make sense so far?
Yeah, so basically you have two separate processes then?
Yes.
So you have MySQL could be, master, a bunch of slaves, it could be a whole.
It could be a raft of them, yeah.
Oh yeah, and then basically one of your processes has to basically listening or connected
Yeah.
to like one of your masters or something.
Yeah.
And then you have a separate process that's a slave as well. Do you
Yeah.
have to have the master and slave as well, or could you just have the master? Like if it was like not mission critical?
Actually, there's a bunch of, this is the simplest one, and I'm showing this basically because our installs support it, so you can get like a one command install to put up a slave and a master. There's a bunch of other topologies. So you can run, for example, you can have the master and the slave replication pipelines in the same replicator. So that would collapse it right down to one replicator. You can have what we call a direct pipeline, where you're going directly out of MySQL straight into Mongo. And that's, our trouble is we don't have the install support for that yet. So I just didn't show it on the picture.
Okay.
Yes?
So I'm seeing very technically how these files are flowing. At a much higher level, you've got in MySQL maybe a star schema that's exploded all over the place with, 10 different tables to put
Right.
together, let's say, an order. And down here in MongoDB, it's a document.
Right.
How do you handle that
We
transformation?
don't right now. So that's, in fact, one of the key challenges is doing the, right now we can move the tuples and it just works, but the transformation is a really interesting problem and one where I'm still kind of noodling about. In fact, if you have suggestions, I want to hear it, because we're sort of, this is like the big problem going, I think, from relational databases into NoSQL. Is if it's key value store, hey, great, because those are sort of really kind of apples to apples, but going into document databases, it's a little bit tricky. So we don't have a good answer to that yet. Here's how you build them up. I won't spend too much on this, but you basically, here's what they look like inside. We have an extractor that comes out of MySQL, and we do a couple things. You have to enable row replication. So you have to do some stuff to add column names and do some twiddling to strip out non-primary key columns. This is just details that we've worked out over the years. But basically, it just puts it into the transaction history log. And in fact, this is just a normal master for us that we use in MySQL replication. What we next do, this is the Mongo one, which is this pipeline which has got the TCP/IP connection to the master. It's pulling from the log. It then writes it into its own transaction history log, and then it has an in-memory queue to Mongo. And basically, you can, the way we set up pipelines is it just split reads from writes, so nobody blocks. Because I/O is the thing where this stuff all gets slow. Java is lightning fast. These individual, the individual stages, they can loop around even on my laptop at over 100,000 cycles per second. They're very, very fast. So we build these pipelines though to optimize I/O. So setting it up, if you use Mongo, it's like trivially easy. Well, it's as easy as MySQL. You just untar it, cd in, make a directory, and then start that. Actually, that should be MongoD, not Mongo. Mongo is the client. You just say start Mongo, bin MongoD, and that's got the data. And then on MySQL, you just enable row replication. And MySQL can replicate either the statements that the client sent or can replicate the row updates. And if you go into Mongo, the statements are worthless, because Mongo doesn't understand SQL. So you basically have to use row replication. Getting tungsten, I'll post these slides, but this is basic. In fact, actually I had a blog article. This is just pulling the latest developer build, and you just, we store them in Amazon, you untar it, and you cd into the resulting directory. This is the next, we're working on the 205 build, so this install support is in that version. And then here's a command to set up a master, and it looks kind of gnarly, but the thing I would point out is it's a one-line command. This sets up a master replicator and basically says I'm a master-slave configuration. My master host here is called Logos. That's the name of one of my computers in my lab. And then just a bunch of stuff, like it tells the filters I need to use, like to add column names, for example. And then there's a setting, for example, if we're processing strings, because we're moving across databases, we're going to need to turn them into Unicode. So this says turn them into Unicode and just start the thing and tell me that you're up and running. So it's one command. And so it's fairly easy to set these things up. And then on the Mongo slave, it's the same thing. It's basically one command. And this stuff is very heavily documented. We have it out, we have sort of a cookbook on the website, and we write very regular blog articles that explain how to do it. So it's pretty easy. Again, it says, hey, I'm a master slave. I'm going to be, where does it say on a slave? Somewhere it will say that. Oh, yeah. So it says where my master host is. It says that I'm cluster host. It says I'm another host, so therefore I must be a slave because I'm not the master host. And this sets it up, and then it starts. And that's basically how it works. So I'll just type these commands in and make it work on my laptop. Let's see where to put my glasses. Oh, I can do it by the large print.
I'll tell you what you typed, don't worry about it.
Exactly. Okay, great. So here's the command. So what I'm going to do is I've just wiped stuff out, and the command here I'm going to type in is a little bit different because I'm running on my laptop. So I have to to avoid port collisions, I have to add a few options. But normally it's essentially doing the same thing. So what I'm doing right now is I'm going ahead and running the commands to set up the master. And it, you know, it kind of burps at you that we don't really support Mac OS X. We really are Linux guys. I mean, most serious computing is done there for the stuff we're working on. So it's basically what it's doing right now is it's taking. I've unpacked the tar.gz, and it really just copies the code out to the place where I tell it to live. It could be on another host, in which case it SCPs it, and the replicator is now up and running. I'll show you proof of that in just a second. So the next thing I'm going to do is install the MongoDB slave, again on the same host, so I have to do a little bit of some extra options, like to set these various ports. Like we use RMI as the administrative port. And it's pretty much the same thing. It pops up, and in fact, it's interesting, it took long enough to pop up that when it lists the status of this thing, it's saying that it got the first sequence number. We've been global IDs start with 0, so it's up, and it came up 40 seconds after the MySQL one, which is why it's 40 seconds behind. And now at this point, if I want to know what's going on, I've got a little script I've written. Oops, let's see where I'm putting it.
So right now you have two separate processes running.
That's correct.
One is the Mongo slave.
Exactly.
Okay.
Exactly, and if I can find my, just a second. So hopefully this is visible. I can show this, basically I'm running commands which inquire the status of each of them. So they're contacting each of the replicator and saying where you're at. And so there's the first one is the master replicator, and the second one is the slave. And if I want to just prove liveness in this system, there's a really convenient command. Let's see if my aliases are set up. So I can run a command called a heartbeat, and it just inserts a row into a particular table. And if I run the services command again, it will.
Caught up now.
Yeah, exactly, because what happened was we pushed something through, and so now we can see that the latency has gone down to a 0.9 seconds. So basically, this thing is up and running. What I'm going to do now is just connect to MySQL and make a table, and then we'll see where we'll see the data replicate through. So here we have. Get my windows up here. This can go away. So on the top here we have we're connected to the MySQL instance. On the bottom here we're going to be connected in just a second to Mongo. And so we're in the test database, we'll do show tables. Nothing, so nothing on MySQL. We'll do a show collections. In Mongo, nothing there. So let's create a table in MySQL called foo, because that's what they're always called. And so that just created a table in MySQL. And the question is, what did it do on Mongo? And the answer is nothing. And the reason is that creating a table doesn't mean much. And the way I implemented it was, we just throw that, it's a statement, we just throw it away. We're going to wait till some data arrives, and then we're just going to let the collection material. So what we're now going to do is put some data in. So we'll insert a row. Let's see, it's here on MySQL. So hello from MySQL, because it's coming out to greet it. At this point, if we show the collections, not only do we have foo, but we also have indexes. And then we actually, Mongo has a really cool query language. It's based on JavaScript. It's very easy. So we can just go ask this table, this collection foo, what's in it. And if we now do that, there it is. So that row just replicated across. And I'm not going to show more replication, but I test this out. One of the ways I tested it was I have a TPCB application, and it runs it, as I mentioned in later slides, it runs at about 1,000 transactions per second on lab machines. It can be optimized a lot more, but it moves data fairly quickly. Another thing that it does is, let's see if I can get this. There we go. One of the things that I ran into actually as a performance problem, this is where it gets very, just an example of the kind of, there's not only the transformation of data, sort of the logical schema, but the other problem that I've run into, which is more immediate, is indexes. And oh, interesting, this is not, what I should see here is, I actually should see an additional index, and I don't. I have to go back and check. Maybe I pulled the wrong, it's possible I pulled the wrong build. But the basic issue that you get is, like if you're going to do updates, and they depend on having an index that corresponds to your primary key that you're coming off, using in SQL to get the row updated. So what I did was put a feature in here, which we're not seeing for some reason, but it basically automatically adds an appropriate index for the SQL primary key. Otherwise, the thing is just dog slow. Now, I need to double check why that doesn't show up, but it should be there. And Mongo is kind of cool because you can add an index to something before you put any data in it without ever mentioning the table, and just puts it out there. Just not today. So that's basically the replication. Let me show you, I think we've got a couple more minutes. Let me just show you a couple more slides. And just some tips. So this is, our goal, like everybody, is world conquest, but this stuff is not going to be defeating anybody anytime soon. I just want to talk about software quality. So, because this is pretty new, and I want to, if you try it out, I want to be very realistic about what you're going to hit. So, the base replication infrastructure is stable. And we have people, I was trying, just calculating how many logs they generate, because we're talking big data a little bit in this talk, and they generate around 0.5 terabyte of logs a day. They have 16 clusters. They do about 500 million transactions a day. It all runs on our replicators. So these are, the individual replicators do 50 million transactions per day or more, day in and day out. So I've just tested it mostly using TPCB. I get about 1,000 transactions per second, TPCB transactions per second, which is pretty slow. In fact, I'm learning that, like Mongo is supposed to be fast, and I think, in theory, all NoSQL databases are fast. I mean, that's why everybody wants them, but actually making them go fast from a client is a little bit different. The data type mapping is just pathetic. Right now, everything goes to a string. We need to fix that so that numeric data types come through. The problem is that JSON doesn't have very much in the way of types. One of the things that would speed it up is to do parallel apply. And one of the really cool things about any database, which is a key value store, or even the document database, is no referential integrity. So if you have a stream of updates coming in, as long as your applications can deal with it, there's no reason why you can't just split them out by table, or even, in the case of Mongo, by document, and just be jamming them in, with a bunch of parallel threads. You can move data very, very quickly that way. Parallelization in SQL is a very hard problem. In fact, just about the hardest one I've ever worked on. But parallel apply in NoSQL databases should be fairly straightforward. It doesn't work right now because we have a couple of assumptions about having some tables in that we need to work, and we need to get them to work properly in Mongo. The other thing I've hit is that the fact that Mongo doesn't have transactions is kind of a nightmare, for moving data. I think you have to, I think we just have to learn how to deal with it. I'm sure there's ways we can make it better, but the fact is that a lot of the ways you get stuff to go in quickly is to do things like block commit, so that you don't have a lot of overhead, like bookkeeping overhead in tracking where you are. And the fact that Mongo doesn't have atomic transactions makes this more difficult to do. And then the final thing is I haven't tested it against MongoDB clusters. This is a single MongoDB instance. So just to be realistic, now, it's not that this stuff is bad. It's reasonable, but you will hit problems. Just provisioning, you can provision using a MySQL dump. That's a simple way to move data quickly, in sort of gigabyte. Yes, please.
What is parallel apply?
Parallel apply means that, so if you have a serialized set of transactions, you're basically going to divide them up into what we call channels. And and apply them in parallel. So, and in the case of SQL databases, it can increase your throughput by a factor of 3 or 4. Depends on your I/O subsystem and some other things, but it can have really profound impact on performance. So we can, for example, take the transactions that we're reading and split them across 30 threads and apply them simultaneously. It's a way to move data in really fast.
That's a great way to just migrate completely to Mongo if you don't want to have a slave relationship.
Absolutely.
Just do that and you're done with it.
Yeah, exactly. So you could just use it. In fact, this is a
Then
way
you can
to
tweak it once it's in there and massage it or whatever.
Exactly. So this is a trick that we use quite a bit going across databases. And the real challenge, and that's I think where it gets interesting, is data transformations. And this is something that kind of keeps me awake at night because we have the ability to filter database. Like a lot of the magic that allows us to, massage transactions so they'll actually be able to apply to Mongo is done through these filters. They're just little plug-in components. They're written either in JavaScript or Java. Eventually we may support other things. But that's a really interesting question, how we morph these transactions. Like if you have a transaction, it might be an insert on MySQL, but in fact in Mongo, it might be an update on a document where you're adding something within a document. So we haven't begun to think about that at all. Haven't begun to think too much about sharding. Sharding is really big in MySQL and what it means for those shards to move across and what the use cases are and what's important. Haven't really worked on that. And then there's this whole question of replication from Mongo back to MySQL. And that I think is eventually, as Mongo systems either succeed and then they need to propagate data back, it'll be important, or they fail and people want to rescue their data.
Have you thought about supporting Hadoop? Because I know there are some companies around here that use that for big data.
Absolutely. In fact, the whole reason we're doing Mongo is in my mind, is in next year we will go for Hadoop, and particularly HBase. That seems to be getting some traction. But I think it's, this problem of replicating between these two things is hard enough. We're just using Mongo, to get started because it's pretty popular, and it gives us, we kind of get our feet wet on some of these issues, some of which are not easy to solve.
And you said you use JSON for the...
Yes,
just
or BSON
send
or whatever they call it.
Okay.
It's actually very, and Mongo, I have to give these guys props. They've done a wonderful job of making the database very easy to use.
Are you using JSON even when you go from, say, MySQL to Oracle or something like that?
We are, actually, that's what we're thinking of doing. Yeah, we're, 30 seconds?
Yeah.
Okay. So anyway, that's sort of it, actually. Oh, final advice. So are you guys at all interested in using this? I hope you are.
I might have a client job,
Yeah.
where I could use it.
So we make our money off services. I am not planning on making much money on this, but I'd love to have people trying it out so we can sort of get a sense of what, and so it is 100% open source. We have this replicator, Tungsten replicator discussed. We're on IRC. We're pretty open about this, and if you use it, if you got something that's got to get deployed on time, you probably want to do services, but also we're just interested in the feedback.
Are you available for consulting if there's some specific
Oh, yeah,
case that's
absolutely.
not supported?
That's a fundamental part of, in fact, that's the way it works. You see something, the Mongo stuff has been all kind of on spec, but generally speaking, the way we build out this replication is somebody sees something they want, they pay to put it in, and we usually underbid it, believe me. Because some of these things just take, how it is with code, it just takes longer than you think, so we're fairly economical.
You do the flat rate, or how do you do that?
We
just
usually
bid
do
a
it
job,
that way,
or-
but then, if you commit to make something work, it's sort of like you're not going to bail on people.
Right,
It depends on how much money we think they have.
right.
And whether it has strategic value. So that's where we are. We have these blogs that explain how to do this. Mine is the top one, Scale Up blog, and that's just the contact information. So if you're interested in it, feel free to take one of my cards, and
I'd
if
like
you
to
want to
know.
try it out, we welcome your feedback and hope you use it.
Cool.
Thank you.
Yeah,
Oh,
thanks.
you're welcome. So where should we be replicating? It sounds like Mongo is, there's some Mongo people. What are you guys using? Just out of curiosity.
I'm not right now, which is why I came here. Yeah.
Have you guys-
We're talking about Oracle and Mongo.
Oracle and Mongo? Yeah, that's why you were mentioning that. So, yeah, we're
But-
real interested in that problem.
The
'Cause there's a
graphing
lot-
databases, Neo4j is really great.
Yeah, I just haven't met too many people who are using those, so,
Right.
but like Mongo, there's a lot of use, and of course, Brazilians.
We've got the use case is an OLTP system that's overloaded with queries.
Mm-hmm.
Looking for somewhere where you can access an order that's outside your OLTP system.
Right.
And, well, the warehousing options, been there, done that, that's not quite where we wanna go.
Right.
We want some kind of real-time replication where you can, customer service, somebody can pull up their orders and see everything about them.
How do you feel about streams?
I haven't used them yet, but.
Okay, so, but you're not like throwing up or anything, so
No.
that's a good sign. You know, because
Right.
I think what we're thinking about doing on Oracle is tapping into streams. Because there's we're using CDC right now because we sort of knew how to do it, but we've gotten feedback from some of the Oracle folks that's not good, but streams is out there, it's fairly high performance API. If we can sort of translate that, we'll then be able to jam data, get data out of Oracle real fast and just jam it into other sources.
Is that just a name, or is that like a real Unix stream?
Oracle Streams, so
Oracle
it's a product
Streams.
within, it's sort of like their replication before they bought Golden Gate.
Oh.
And now they're just like, they don't even like to talk about it, because they wanna, they wanna sell Golden Gate, which is really high priced. So I was looking for.
So they may not support it, right?
No, I know the people who work at Golden Gate, because we used to all work together at Sybase, so they're gonna support it, but the Oracle sales guys don't wanna hear about it, because they can't charge money. It's licensed, it's bundled in with Enterprise Edition, so they can't make money on it. Okay, I think it's time for Cassandra. We should hail them in.
Politics is a big company.
Yeah, well, hey guys, thanks for listening. I really
Yeah,
appreciate the opportunity to talk about it.
Yeah, you said you had cards, could I have?
Yeah, absolutely.
I was actually on the phone with a potential client today, and it's going through MySQL to
Yeah, let me see. There you go.
A lot of these Rails-based apps around here, it's monkey see, monkey do, so they're all crazy about Mongo right now.
Oh, absolutely.
Talking Mongo, so.
Oh, yeah. So, my name's Robert, and you're? Glad to meet you. And did you want one or?
Right here.
Oh, okay. Give me a call. I won't be, I'm not going anywhere. Yeah. That's right, it's sort of based on AQ. It's funny, I developed the Sybase competitor to AQ. It was about the time that Sybase just kind of came on the world. But yeah, AQ is another one that's been around for a long time. So do you, are you programming against it, or what's? Oh, okay. Right. So you, how long have you been involved in this? I used to run a website, and I think that, actually, because every time I ran into it, it's super
Yeah,